so let's take a simple example and talk through the steps. All right, so the way that this first example is set up, okay, there's a handful of steps that you want to follow in working with exponential equations. And again, these are equations that have variables in the powers. Okay, the first step is to make sure that you rewrite all your expressions in terms of the same exponential base. Okay, and so this first example that we're looking at already has the bases the same, right? Each side of the equation has a single base. The base is a 5 for each of them. So you don't have to go through any different steps on this. Your expressions on each side of the equation already written as a single base. Okay, if they're not already written that way, that's your first step. Okay, once you have them written in terms of the same exponential base, you're then going to equate the powers. Okay, and so what that means is you're going to take whatever the powers are. In order for this whole equation to be equal, this power on the left has to equal the power on the right. Right? That gives you equivalent expressions. So our next step is to take 3x, set it equal to the power of the other side, x plus 8. Okay, and then once you equate the powers, you can then jump to the last step, which is to solve your equation. Okay, so take whatever that resulting equation is. In this case, it's a linear equation, and you solve it. And so for linear equations, or anytime you have just a single x term, here we can combine our like terms. We get 2x is equal to 8. Divide both sides by 2. We get x is equal to 4. Okay? And so that winds up being your solution. Right? It's always a good idea to check your solutions to make sure they work. And so just test and see. Is it true that 5 to the 3 times 4 is equal to 5 to the 4 plus 8? 5 to the 12 is equal to 5 to the 12. So it does check. All right, I want you to try one more. It's slightly more difficult. We add the first step into it, but I want you to try on your own. See if you can solve this equation, please. So the first step is to rewrite the expressions in terms of the same base. So can you express 16 and 4 in terms of the same base? Yeah, 16 can also be expressed as what? 4 squared. So if you reassign that as 4 squared, you now have the first rule met. Each side of the equation is expressed as an exponent using the same base. So then you can equate their powers. So 2 has to equal x plus 1. And then finally, you solve this resulting equation. Subtract a 1 from both sides. You get x is equal to 1. And so now we can check it. Is it true that 16 is equal to 4 to the 1 plus 1, or 4 squared? Yes. So it checks, and you get your solution. All right, let's try one last example here. All right, so this is still considered one of the more basic types of forms. The difficulty comes in as far as rewriting the basis. It does take a little bit of work, okay, but there's no additional work beyond that. So when you look at these, can 9 and 27 be converted into an exponential form with the same base? Yeah, what would the base be? Each of them can be expressed as a base of 3. So 9 is 3 squared to the x plus 1. 27 is 3 cubed to the x minus 1. So continue to simplify here. We do have to apply the properties of exponents. When you take a power to a power, you do what with their powers? You multiply them. So 2 times x plus 1. Here we get our base 3. Again, power to a power, you multiply. 3 times x minus 1. And so once we get to this step, both sides of our equations are the same exponential base. So we can now equate their powers. I'm going to do that over here. So we get 2x plus 1 is equal to 3 times x minus 1. And once you equate the bases, you can then solve the equation. So it's still a linear equation here, so we distribute our 2, get 2x plus 2, distribute our 3, 3x minus 3, and solve our resulting equation. So combine all the x's on one side, move the constants over to the other side. So we get 5 is equal to x. So here's our answer. Let's test this back into the original form. Now, if we go all the way to the original form, 9 to the 6th, is that equivalent to 27 to the 4th? It's not necessarily easy to see it in that form, so let's move down to this step right here and test. 5 plus 1 is 6 times 2, gives us 3 to the 12th. And is that equivalent to, here, 5 minus 1 is 4 times 3, 3 to the 12th. Yes, it checks, so we have our solution.